All right, so again, initially when you first look at something like this, you're thinking, is this even separable? Well, right now it might not be so clear, but we know the goal is to be able to show as a function of something a function of y times something a function of x. So when you see something like this, it's got to be something about factoring. And the fact that there are 4 terms, it's a great candidate for factor by grouping. So let's do that. So we're going to look at the first 2 sets of terms. In the first 2 sets of terms, I can factor out an x, and I'm left with a y plus 3. And then I'm going to factor out a 1, and I'm left with a y plus 3. All right, so that's kind of the hint you get. You know you did it right because the parenthesis terms match. Then down below, GCF would be x and y minus 2. And then plus 4, and that's also y minus 2. Okay, so dy over dx, and that gives me x minus 1 times y plus 3 over x plus 4 times y minus 2. Okay, so it is in fact an illustration of the product of 2 an x function and a y function, so that's good. So then we just need to move terms around. So on the left side I'll have a y minus 2 over y plus 3 dy, and on the right side I'll have an x minus 1 over x plus 4 dx. Okay, now at that point we just want to integrate both sides, but what integration technique kind of makes the most sense? So there is an integration technique with ln. If you remember the derivative or the integral of du over u was the ln of u, right, plus c. So maybe that's something I want to kind of bring up, but well, let's try that technique. So integrate both sides, and let's focus on the left side for right now. So let's let u equal y plus 3, and then du would equal 1. But more specifically, if y equals u equals y plus 3, what does y equal? So y would have to be u minus 3. So I can come up into that expression and I can replace the y with the u minus 3. So that gives me u minus 3 minus 2 over u du. And like I said, we'll come back and deal with the x here in a second. So that's u minus 5 over u. And this then I can split up into 2 separate fractions. So that's u over u minus 5 over u du. And so that's going to give me 1 minus 5 over u du. And that then fits our ln approach. So that would then, so the integral of 1 is u, and minus 5 ln of u. Okay, and then let's go back and let's do some substitutions here. Okay, I'm actually going to simplify something real quick. So I'm right and I'm wrong at the same time. So here's what I'm going to simplify. So I'm going to integrate this as 1 dy, because I don't really want to do a variable swap if I don't necessarily have to. And then this one is going to be the integral, and we'll put a 5 on the outside, of du over u. And so that'll give me a y minus 5 of ln of u, and then I can substitute back in that expression in terms of y then. So that's ln of y plus 3. Okay, so that's all on the left side, and we're going to do a similar technique on the right side. So process is going to play out pretty close to the same thing. So let's come back up here. Let's see, so what do we have? I'm going to just focus in on this right side here. So integral of x minus 1 over x plus 4 dx. I'm going to let u equal x plus 4. So du would equal just dx. And then, oh, I forgot that over there, so that should be dy. Hopefully y'all weren't screaming at me at home. And then x would be u minus 4. So let's do all that substitution in. So we got integral of u minus 4 minus 1 over u du. So that would be 1 minus 5 over u again. And let's see, so this one, that's going to be dx. And that's the integral of, put a 5 on the outside, so du over u. Alright, so that's x minus 5 ln of u plus c in this case. So we get x minus 5 of ln of x plus 4. And then we'll plus c it. Oh, I don't need that integral there. Okay, so let's put all of this together. So we have y minus 5 ln of y plus 3 equals x minus 5 ln of x plus 4, and there's our plus c. Alright, and I want to go one more further step, just because I can see there's a way we can simplify this additionally. So there's another form we could write this in, so I know sometimes the homework answers are going to force a certain direction on you, so let's do a little bit of review of some exponent rules. So I'm going to put those ln statements together. So let's see, if I bring the ln of x plus 4 over, and let's put those 5s up as exponents. So that's ln of x plus 4 to the 5th minus ln of y plus 3 to the 5th equals x minus y plus c. Okay, and now what? Okay, so we have our log rules. Say if we're subtracting, we can convert that into division. So that's ln, and we have an x plus 5 and a y plus 3, both to the 5th power, equals x minus y plus the constant there. Okay, and I don't need that inside parentheses that I started writing there. And then what we're going to do is we're going to raise both sides to an exponent. So we're going to say e raised to the ln of x plus 5 over y plus 3 to the 5th, which is just going to simplify to give us x plus 5 over y plus 3 to the 5th on that side. And on the right side, we have e to the x minus y plus c. And I'm going to do something a little clever with that constant term, because if you're adding an x, so if it's plus c there, I can convert that into e to the x minus y times e to the c. Because again, it's a constant, it's just a number. You give me some initial conditions, I can solve for what c is, so who cares what form c is in. And to make it a little bit simpler, I'm going to rename this thing, because again, it's a constant, so I'm just going to rename it as some constant in terms of c. So x plus 5 over y plus 3 to the 5th equals C1. So just some form of C, some constant, given some initial conditions, e to the x minus y. Okay, now I'm going to identify this. I worked really hard to get that nice pretty answer there. But our initial answer was actually fine. Then we got way up there. All I was doing from the first box down to the second box was just using some exponent rules and some log rules to simplify our expression even further. So if I have some sort of initial conditions, that's a little bit of an easier equation to solve than maybe that initial expression was. So here's my 2 cents on this. Would I expect all students to always write their answer in the second form? No. Would I expect students to understand the rules that I use to get to the second form? That is a yes. First form is fine, but again, you got to go with directions on what Cengage is going to ask you to do on the homework, and then whatever the test directions are. But I would expect students to be able to follow the logic on that. So hopefully I didn't lose you too much on that.